Hello again, and for our last section on matter, we are going to talk about separating mixtures. We talked before about mixtures, and now we're going to look at how can we separate a mixture that we have. So what if we have, right here, a mixture of salt and water? Remember that it is a solution and a homogeneous mixture. It might be a little bit more difficult than pouring it through a colander like you do with spaghetti and water. So I want you to think for just a minute, how could you separate the salt and the water from each other in this mixture? Well, I'm going to offer you a really great idea called distillation. It is a physical method of separating something in a mixture. And here's how it works. We have right here our mixture. We have our salt and our water that's all mixed together. And here's a little Bunsen burner applying heat to that mixture such that the water produces steam, and some of that water evaporates up in our flask here. And then as the steam comes down here, it cools. This is the condenser, it has cold water around it, and as it cools, the molecule, or the water molecules there, those molecules will condense, and they condense back into a liquid, and the liquid is collected here in this flask. So this is a really effective way to separate a liquid from something like salt or another solid that's been dissolved in the liquid, and we'll end up here with salt and here with our distilled water. Here's another method. This method is called filtration. It's also a physical method, and we're going to look at this when we're talking about separating a heterogeneous mixture. Here I'm using the example of sand and water. I don't know if you've ever tried to mix up sand with water, but it doesn't really mix very well. You end up with a very heterogeneous mixture with oftentimes the sand just sitting on the bottom of the beaker. So here we're going to pour our sand-water mixture into a funnel, and right here the funnel is lined with filter paper. The filter paper allows the water to pass through, and it captures the residue of sand. So here we get our liquid or our water down at the bottom and the filtered solid right there. Now both of these methods are physical methods because we do not change the substance of the things in the mixtures. So as in the distillation, we start with water. It's still water in the gas state. We change states, and then it's still water back in the liquid state. Here we also do not change the substance of any of these things. They are still the same substances. So we call these physical methods of separation. Now what if we had a solution that had all three things in it, sand and salt and water? Well, we are welcome to use filtration and distillation together in order to separate these things. So if we first filter the mixture with filtration, use a filter paper, we can end up just collecting the saltwater solution and separate out the sand. And then if we take our saltwater solution and perform distillation, we can end up with pure water, or pure water as well as the salt too. Those can both be separated. So we can use those in combination in order to separate more than two substances that are mixed together. So here's a little flow chart for you. If you want to think about matter being either, it could be a pure substance, it could be a homogeneous mixture or a heterogeneous mixture. In order to separate these mixtures out and get our pure substances back, we can use physical methods of separation. And pure substances are going to be either elemental or they're going to be made up of compounds. In order to get elemental substances, we will need to use chemical methods to change compounds into elements by breaking those bonds and breaking the compounds down into the individual elements that they're made of. So that should give you an idea a little bit in your mind of how we can break matter down and separate it. So, above and beyond, how could you do that? Well, I have a really great idea for you guys today. You're welcome to come up with your own ideas. I love that because I know you're all so creative. But if you would like to research more separation techniques, there are many others that would be wonderful to look into. Tell me how they work, what kinds of mixtures they are effective for, and can you give examples of situations where certain techniques prove useful? And any other great explanations you have about different separation techniques, that would be wonderful. So we'll see you in class. Bye.